Hi guys, welcome. Today is day 26, wrapping up this last unit of the semester. All right, so today we are looking at lesson 72 and 73. So the first lesson we're looking at is problems in which we're going to have to use multiple unit multipliers. So again, a unit multiplier is something that's just equivalent to one, but we use it to convert units, feet to inches, hours to minutes, kilometers to meters, or whatever it is. So that's just a unit multiplier. Like 1 foot is equal to 12 inches. So we can do 1 foot over 12 inches or 12 inches over 1 foot. So that's a unit multiplier. But there's some examples and some situations where we're going to have to use multiple unit multipliers. So again, don't try and save steps and do it all mentally or quickly. Write it out so you can make sure that you're canceling out the units you need to cancel out, and then you're ending up with the units that you want to end up with. And again, a unit multiplier being equal to 1, we're not changing it. We're not making, if we're talking about a distance, we're changing it from inches to yards, and we have to go to feet, then to yards. We're not changing that actual distance. We're just writing it in a different unit. So it's still whatever we're multiplying by 1, by 1, by 1, depending on how many unit multipliers we have to use. So we're not changing anything, making it bigger or smaller, or if we're talking about time, making it longer or shorter in duration or anything like that. Okay, so example 1, the Ortegas want to replace the carpeting in some rooms of their home. They know their square footage of the rooms is 855 square feet. Since carpeting is sold by the square yard, they want to find the approximate number of square yards of carpeting they need. Use unit multipliers to perform the conversion. So the temptation would be, oh, I know how many feet are in a yard. There's 3. So we just need to divide by 3. Well, it's, again, square feet, and I've known of people doing this. They do a quick conversion. They end up with way more of something that they need or way less of. So it's important to make sure that you are accurate. So we have, what did we have? 855 square feet. Or again, that's feet times feet. Because when we talk about area, we're multiplying feet times feet. That's where we get our square footage. So I want to get rid of square footage, and I want to end up with square yards because that's what it's sold in. I don't want to just go and say, give me 855. You're going to pay way more money than you need to because you're going to get 855 square yards. So we want to convert it. So I'm multiplying, again, feet and feet. Feet squared is in the numerator right here, so I want it to be in the denominator. Okay, so feet. So 3 feet is equal to 1 yard. But that's only going to cancel out one of these, so I have to use 2 . I have to use 2 in order to get rid of my square footage. So again, not changing the dimensions, but we need to convert them, and we need to use 2 unit multipliers because we're trying to get rid of square feet and end up with square yards. So again, feet times feet would be square feet. So these feet times feet are going to cancel out the square feet right there. Then I'm left with 855 times 1 yard times 1 yard, which is 1 square yard. So this gives me 855 square yards, but then I still have a 3 here and a 3 here. So 3 times 3 is 9. So 855 divided by 9 gives me 95. So 95 square yards. Again, if I went in and got 855, or even if I just divided by 3 and said, oh, well, there's 3 feet in a yard, so just divided by 3. Now it's a square square foot to a square yard, which there's 9 square feet in 1 square yard. So that's why we had to use 2 unit multipliers in order to get rid of square feet. You just divided by 3. That would have been 285. You go in and do 285 square yards of carpeting or flooring or whatever you're purchasing, you're going to have 3 times more than you need. Then you got to return it or whatever. It goes from there. Okay, so that's why we multiplied it by our unit multiplier, and we had to use the same. It's not always going to be the same unit multiplier. Sometimes it is. But in this example, we had to multiply by this unit multiplier twice in order to end up with the units that we wanted. Let's look at one dealing with volume. So concrete is delivered to a job site in cement trucks. It's ordered in cubic yards. Ray is pouring a concrete driveway that is 18 feet wide, 36 feet long, and 4 inches or 1/3 of a foot thick. Ray calculates the volume of concrete he needs in 216 cubic feet. So that part's done for us. Use a unit multiplier to find the number of cubic yards of concrete Ray needs to order. Getting it all in feet, and then finding the volume, making sure we do that portion correctly. 18 by 36 times 1/3 gives us 216 cubic feet. Again, we're talking about volume, so again, 3-dimensional. We're going to need to use 3 unit multipliers. If we just divide by 3 or even divide by 9, we need to divide by 27 because we're using 3 unit multipliers. Again, cubic feet is feet times feet times feet. So that's why we need 1, 2, 3 in order to get rid of the cubic feet. So I get 216 times 1 yard times 1 yard times 1 yard, which is 216 cubic yards. And then we had 3 times 3 times 3 still in the denominator, which is 3 cubed, which is 27. 216 divided by 27 gives me 8 cubic yards. So again, very important. You don't want to be way short on the job, but you don't want to purchase 3 or 9 times or whatever more than you need. That's a lot of money and a lot of wasted materials. Okay, so if it's one-dimensional, if we're talking about perimeter or something like that, we're just converting one time using 1 unit multiplier. More than likely, unless we have to convert from inches to miles or something, we do inches to feet and then feet to miles. But if it's shape that we're talking about, if it's one-dimensional, 1 unit multiplier. If it's 2-dimensional, we're finding area of a polygon or some sort of surface area, then it's going to be 2 unit multipliers. And then if we're talking about volume, since it's 3-dimensional, we're going to have to use 3 unit multipliers. So that's why I write it out versus just trying to jump right into the division. What is going on? Well, we need to cancel out 1, 2, 3 feet, okay? Units, not 3 feet, but 3 units of foot. So foot, foot, and foot. That's why we have 3 of them, because we need to get rid of cubic feet. So that's where we get this. Keisha set a school record running 440 yards in 1 minute, 60 seconds. Find Keisha's average speed for the run in miles per hour. 1 mile is 1,760 yards. And so we want to figure out miles per hour. So we know how far she ran. We know how long it took her. But then how can we use that information to figure out miles per hour, average miles per hour? And 440 yards, you may have sped up or slowed down at some point in that race, but you can figure out on average how fast were we traveling. So 1,760 yards equals 1 mile, because I want to end up with miles per hour. Okay, so I have 440 yards, which is what we were given right here, over 1 minute. That's my rate, so that's what I start with. So that's my first fraction that I write out. And then I know 1 mile is equal to 1,760 yards. Okay? And then 60 minutes is equal to 1 hour. I want miles per hour, so I want miles to end up in the numerator, and I want hours to be the only units that's left in the denominator. Okay? So we do 440 times 1 times 60, okay? And then 1 times 1,760 times 1 hour. So I get 440 times 60 divided by 1,760. And that ends up being 15 and then miles per hour. Okay, so just write it out. What are you starting with? What are you trying to end up with? And then what unit multipliers do you need to cancel out the units you need to cancel out and end up with the units that you want to end up with? So it may take some time. It may take a little bit of showing your work as always. So just write out what you have, however many unit multipliers you need to use, and then just simplify and cancel out. Okay, we'll go over that practice set when we get to class. Lesson 73, we are looking at formulas for sequences. And we talked about sequences in the past. Similar to a function, we have an input and an output. Usually we use A for the value, N for the number of term of the sequence. So that's where it's a little bit different than a function. We can't have negative numbers. We can't have 0. It's always the first term, second term, third term, fourth term. But again, we can input number of term and calculate the value, or we can be given a value and calculate what number of term it is. We have arithmetic and geometric, and then other types of sequences. Again, the first term is always 1, then second, then third, then fourth. So this one isn't necessarily linear, or where we connect all of the dots if we were to graph it, but it is going to be similar to a function. It's going to be a rule that we can put in a number for n, 1, 2, 3, 4, 5, or whatever, and then calculate a value based on that, because the sequence and the formula for the sequence is going to remain constant all the time. So if we have an n, a number of the term, plug it in, and we'll get a value. So that's where it's nice versus, for this example, 3, 6, 9, 12. Okay, well, it looks pretty obvious that we're going up by 3 each time. So the number of the sequence times 3. So 1, 2, 3, 4. If I asked for what's the 50th term, we can go 3, 6, 9, 12, 15. Do that 50 times, or, once you understand the rule, that's going to save you a lot of time. You can just plug in 50 for your n, and then that's going to tell you your value. So 3 times 50, the value at 50 is 150, because it's 3 times the number of the term. All right, so if we have that one we just looked at in the example, a of n equals 3n. Again, this isn't a times n. The subscript just means a in terms of n. So when we're given this number right here, like in this example, this isn't a times 8, and then we're dividing or anything like that. All this is saying is for n, since this is the placeholder for n, and then n is in our rule, it's always in our rule, we're just plugging in 8 for that number. So 3n, or 3 times 8, is 24. And a of 9, well, put in a 9 for n. 3 times 9 is 27. When a formula is not given, be creative when looking for the rule or pattern of a sequence. This is where, it may take you some guess and check, or really looking at it to try and figure out what's going on. Sometimes you can see it right away. Other times you think you have it, and then, the third or fourth or fifth term doesn't work out to be true. So you got to kind of just look at it and figure out what's going on. It's always easier, at least in my opinion, to have the rule and try and find the sequence versus being given the sequence and trying to work backwards to find the rule. But it is something that we can do. All right, so if we have a 2, 4, 8, 16, 32. Well, I'm adding 2 or multiplying by 2, or really doing 2 to the power of 2 from 2 to 4. That's where only having 2 terms doesn't really help us out, because we're going up by 2, but then from 4 to 8, Okay, I'm going up by 4. From 8 to 16, I'm going up by 8. 16 to 32, I'm going up by 16. So it looks like we're adding, we're doubling the number, and that gives us our next number. So we're multiplying by 2. So 2 times 2, 4 times 2, 8 times 2, 16 times 2. B is one that obviously doesn't look as obvious. Well, 1, 1, 2, 3, 5, 8. Okay, that one might be a little trickier to figure out what's going on. We have a 1 and a 1. So how do we, we're not adding something to get from 1 to 1. Are we multiplying? Are we doing a power? We have 1, 1, 2, 3, 5, 8. So we're doing maybe doing 1, maybe plus 1 equals 2, 2 plus 3 equals 5, 3 plus 5 equals 8. So doing previous two terms added together to give us our next term. 1, -2, 2, -1, 3, 0, 4. Again, that one's, well, we're bouncing back and forth between positive and negative integers, so that one isn't as easy to come up with. But if we have 1 times -2, or 1 minus 3, I guess. Yeah, that one is really tough to come up with. So let's see what's going on. So that one, we have an alternating pattern. We minus 3, then add 4. So again, if you're only given 2, 3 numbers, it might be, especially like B or C, really difficult to try and come up with. But once we take it out a little bit further, we have from 1 to -2, we're minus 3. And then from -2 to 2, we're plus 4. From 2 to -1, minus 3. -1 to 3, we're plus 4, and so on and so forth. So it's going to be every 2, I guess, is going up by 1 because we minus 3, then add 4. Minus 3, add 4. Minus 3, add 4. So it's going to be that same kind of pattern all the way. Okay, then we can have sometimes where the number, or n, is in our exponent. So a of n equals 2 to the power of n. Well, when a of 10, well, we plug in a 10 for 2, and that gives us 2 times 2 times 2 times 2, or that would work all the way out to be 1,024. So again, whatever n is, if we're multiplying or we're raising it to a power, or that is the power that we're raising a constant or a coefficient to, you just plug in whatever value is in this position, representing our subscript, our n, put that in for wherever there's an n in the rule, and then just calculate it out. So 2 to the power of n. We could do 2 times 2 times 2, or we could just do 2, hit that up arrow on the right side of your calculator, 10, and get our solution. This one's pretty straightforward. We just have 2 times a number and then adding 1 to it. So we may go 3, 5, 7 versus 2, 4, 6, 8. And that's why it's going to be similar to that pattern, but it's just going to be odd numbers because it's 2 times a number and then we're adding 1 to it. So it's always going to be odd. The numbers in the sequence are sometimes called triangular numbers. 1, 3, 6, 10, 15. These numbers of objects can be arranged. We have 1, and if we make a second row with 2, we're going to have 3. Third row with 3 is going to be 6. Fourth row, 10, 15, and continuing on. Triangular numbers, this one would be a little bit more difficult to just kind of come up with in looking at these few numbers. Okay? But triangular numbers can be found using this formula. A of n equals n times n plus 1 divided by 2. So 1, if we had a of 1, 1 times 2 divided by 2 is just 1. If we had 2, the number of the sequence, well, 2 times 2 plus 1, which is 3. 2 times 3 is 6, divided by 2 is 3. And then we put in 3. 3 times 4 is 12, divided by 2 is 6. So it's going to obviously follow that same pattern that we just saw in these numbers and continuing on. But versus trying to do this, imagine your third row, fourth row, fifth row, sixth row, seventh row. And you can just plug in the number to this formula and save time. So instead of doing this, 1, 2, 3, 4, 5 terms. If we needed to find the 10th term, it'd be much easier to just plug in 10 for our rule. 10 times 10 plus 1, which is 11. 10 times 11 is 110. Divided by 2 is 55. So just look for that. Sometimes we'll be given the rule and we have to find a value. Sometimes we'll be given all of the values of our first, second, third, fourth, fifth, whatever terms, and then we have to work backwards to find the rule. All right, that's all we have for today. So we will see you guys in class. Thank you. Talk to you soon.